Welcome to Wassce TV. We are here once again. I'm still your mathematics facilitator. We are going to look at the question 3 of the paper 2 of Wassce 2025 core mathematics. So I will not waste my time. Let's go through the question and see how we can solve this question. Now, in this question, we are saying that the contractor builds a rainwater collection system in a shape of a hemispherical tank of radius 2 meters to irrigate a 500-meter square farm. And each square meter of the farm requires 50 liters of water. And we are to determine with a mathematical statement if a full tank of water would be sufficient to irrigate the farm. And then we should take what power to be 22 on 7. So this is one of the concepts of the senior high school mathematics, that is mensuration. So if you go through mensuration, we have mensuration 1 and mensuration 2. Yeah, so this concept will be, or you can find this concept in mensuration 2. Yes, mensuration 2. Yeah, so that is the one of the concepts based on this question. So let's quickly look at it. So for this question, you need to know what a hemisphere is, and a sphere is when we talk of a sphere. So you can see this nice diagram, or this nice picture here. So a sphere is in this form. It's a circular form. So this is what a spherical tank. Okay, yes, this is a spherical tank. So let's take this picture as based on the question. Let's take this picture. So let's assume that this is the farm. Okay, yes. So this is a spherical tank, but in this case, in the question didn't mention what a sphere. The question rather mentioned what hemisphere. So it is a sphere, from a sphere that we can get what a hemisphere. So if you know, or if you have a sphere, then you can get a hemisphere from it. So if a farmer or someone has been able to build this spherical tank, then from this spherical tank we can also build what a hemispherical what tank. Okay, and when we talk of hemisphere, because we are dealing with hot water, then we have to look out for the volume of the water. Okay, how much volume do we need for the 500-meter square what farm? That's what we are looking at. So we have to know the volume of a sphere, which is given as what 4/3 pi r cube. So this is what the volume of a sphere. So how do you get hemisphere? In this case, we are saying that hemisphere is what half of what a sphere. So when you divide a sphere into two equal parts, then you get what a hemisphere. Okay, so this contractor, instead of building this sphere, he decided to build what a hemisphere, which is half of this. Okay, so if you divide this sphere into two equal parts, then you are going to have what we call what a hemispherical tank. So this is the tank that the contractor decided to build for the irrigation process for the farm. Okay, that is, he decided to get half of it. So if we are saying that a hemispherical tank is half of what a sphere, then what will be the volume? The volume is just a matter of what and we are also giving a radius as what 2 meters. Okay, so you see where the radius is. The radius is what also half of what the diameter of what of the hemisphere, or of the sphere. Okay, so that is the 2 meters. If that is the case, then what will be the volume of the hemisphere? Then we need to multiply what half. Okay, we multiply half by the volume of a sphere, and that will give us what what we call what spherical. Yes, so that's it, just half of it. Then we just cross out. 2 divides to how many times 1, and divides for how many times 2, and that gives us the final volume of the hemispherical tank as what 2/3 per r cube. Okay, that is great. If that is the case, then let's proceed and find what is the exact volume of um, the tank the contractor decided to build, whilst we are given the 2 meters as our radius, and we also to take what power. We just move on and do substitution. Okay, good. So once we have power radius, which is r, as 2 meters, and the power also given as 27, 22 on 7, then we can just substitute our values, which is 2/3 multiplying what 27, and 22 on 7 multiplying 2 meters cube. Okay, yes. So if that's the case, then if you multiply, when you multiply the numerator, you know that you are going to get what um this is what you are going to get, exactly 44 on 21, with multiplying 8 meter cube. And when you further multiply, this is what you are going to get. That's 352 divided by what 21 meter cube. So let's try and divide and see if you get decimals for that. And for this one, as our decimal, we are going to get what is it? That is 16.7619 meter cube. So please, this one we've just approximated to 4 decimal places. Okay, that's not all the decimal values there. I've just approximated to 4 decimal places. There are other decimal numbers. Okay, good. So this is then what the volume. Okay, that is the volume that we have. Okay, but note that because we are saying that we are giving what water in what liters. Okay, we are giving water in liters, then we need to change this volume to liters. Okay, yeah. So in the conversion of the liters, we are saying that 1 meter cube is equal to what 1000 liters. Okay, 1000 liters. So it's just a matter of multiplying the 16.7919 meter cube by the 100 liters and divide by the 1 meter cube. Okay, so this is what we have. We have this. So when you multiply by this, then you are going to get 1000, or yes, you are going to get 16,791.90 liters, and this is also approximated to 2 decimal places. Okay, good. So this suggests that this is what the volume of water in a full tank, which is what approximated, okay, to 16,791.90. So that is how to go about it. Okay, so you see that it's very easy. Okay, so once we are able to calculate for the volume of water in the tank built by the contractor, then let's also look at the total volume of water the entire farm what will need or require for the irrigation. Okay, great. So if that's the case, then we as it was given in the question, that the total area of the farm as what 500 meter square. So if you take the whole farmland, the area of that farmland is given as what 500 meter squared. And we are also saying that the volume of water per square meter is 50 liters. So it means that if you take the entire land, okay, every square meter of the 500 meter square needs what 50 liters of water to be able to what do the irrigation process. Okay, that is great. Okay, so that is what we are saying, because we are saying that the total area, the area of the farm is what, 500 meter cube. Then if you take each square, okay, each square, then that square of the 500 meter square will need what, 50 liters. If that's the case, then how do we get liters of water to be able to fill the, or to um, get the irrigation for the 500 meter square land? That's what we are talking about. If that's the case, it's just a matter of what, multiplying the 50 liters by the 500 meter cube. Then you get the total volume of water that required for the entire farm. Do you get it? Yes. So this is just basic. It's very easy. So what that we do is we just multiply the 500 meter square by the 50 liters, because we need to leave our answer in liters. Then we need to divide by what, 1 meter what square, so that the meter square can cancel out, and then our answer will be left in what, liters. Then if that is the case, what are we getting? Then we are going to get 25,000 liters. So it means that um, if you take the entire farmland, okay, which is the 500 meter square land, the water, or the volume of water needed for such a whole land will be what, 25,000 liters of water. That is what we are talking about. Okay, good. But uh, previously we said that the contractor rather built what, a hemispherical tank. Okay, and we have already calculated that the volume of the water in that hemispherical what, tank. So you ask yourself, if you have a whole land of what, 500 meters square, and you also build a hemispherical tank, okay, will that volume of water, or will the volume of the water in the spherical tank be able to sustain that 500 meter square land? That's what we are talking about. Okay, so you realize that the water, because we are saying that every square meter you need 50 liters. So if you need 50 liters for every square meter of the land, then the total volume of water we need will be what, to 25,000 liters. But remember, when we calculated for what the contractor built, we got about, I think, 16,000. Yes, which is very less. So in that case, will you say that um will the tank, or the water in a full tank be sufficient for the irrigation process? Then you can easily conclude that no, there is no way. Because if you say so, if we are comparing the two volumes of water, it is clear that the volume of water in the full tank is less than that of the volume of water required to irrigate the farm. And that is what, 16,791.90 liters, which is less than 25,000 liters. Have you gotten that? So you see that the farm rather requires more. Okay, the farm requires more liters of water as compared to what the contractor had to build. So in this case, we can conclude that that therefore what, a full tank of water wouldn't be what, sufficient to irrigate the farm. Okay, so that is the question. That is what the question asks, and that's all. Okay, so you see that this question is very basic. So when you get questions like this, my dear student, take your time, relax, you get everything all right. Okay, so if that's the case, then let's end here and continue next time. My name is Evans Okay. I'm your mathematics facilitator. This is Mazris TV. Kindly subscribe to our YouTube channel. So we shall meet and continue next time. See you next time. Bye bye.